I request Dr. Surekha to please go on.
Good evening, sir.
Good evening.
Friends. I'm very much delightful to welcome again Dr. G.K. Avari, sir, Head of Automobile Engineering Government Polytechnic College, Nagpur, Maharashtra State, India. We are grateful to have you again, sir, with us, sir. We look forward to another engaging and knowledge-packed session from you. Already we had Dr. G.K. Avari on second day of the FDP for the fourth session. Now I directly invite request Dr. G.K. Avari, sir, to start the session.
Okay, thank you very much. Thanks a lot. I hope that I am audible to all of you.
Yes, sir.
Yes, sir. Yes.
Okay. So at the outset, let me congratulate the Dr. Wadekar, the principal of the PES College of Engineering, Chhatrapati Sambhajinagar, and the coordinators and the Department of Civil Engineering and the IQAC, Dr. Undirwade sir, DN Kekade sir, and SV Munde sir, and all the members of the civil engineering and the IQAC members for taking the initiative to organize this 1 week faculty development program for in the online mode and for the betterment of the faculty members or the technical fraternity. I am happy to see that in last lecture also there were more than 100 participants, those who were logged in to the expert lecture, and also it was cautiously observed by me that they were listening to the lecture, and also the last they have asked me some questions regarding this basically the solar energy or the net zero emission. So today's topic of my discussion is basically the electric vehicle and the electric vehicle e-mobility and for the sustainable technology. So once again, let me congratulate all the organizers from the PES College of Engineering for the thinking about the betterment of the faculty member. And let me share my screen. Okay. Is it visible, sir?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Thank you. Thank you. So this is one of the expert lecture which recently I have delivered at the Engineers Forum in the Institution of Engineers local center, Amravati local center, and we were talking about discussing about the electric vehicles mobility and the innovation, particularly for the sustainable technology. So if we look at the development of the electric vehicles in the entire world and in the entire India, the automotive sector, it basically contributes for the $93 billion US dollar Indian automotive industry is there. We are the second largest two-wheeler and the bus manufacturer, fifth largest heavy truck manufacturer, sixth largest car manufacturer, and eighth largest commercial manufacturer. Okay, once upon a time, nothing was manufactured in India. Okay, when we got independence in 1947, we were not able to manufacture a needle, and needle was not manufactured in India, and we were like a very poor country. And now we can see that the Indian automotive sector, it is placed at the very good position amongst the world position, and we are even contributing and exporting our vehicle out of the country. So this is what the development of the two-wheelers, 79% of the total number of vehicles buses and large good vehicles like trucks 3% of the total number of vehicle, premium four wheelers 2% of the total number of vehicle. So if you look at this total scenario, the Indian automobile industry, it is being particularly grooming up, and it has grown to such a level. Now the other countries look at us as a potential exporter or the potential manufacturers of the automobile vehicles in the India. Now let us see the what is sustainable technology, how the electric vehicles can move toward the sustainability. So if you compare the electric vehicle and if you compare the IC engine vehicle, you will find that the IC engine vehicle left hand side picture, you can see that there are around 2000 plus moving part, and in case of the electric vehicle only 1818 moving parts are there. What does it indicate? That we as a mechanical, electrical engineer, civil engineer, we calculate the reliability of the system. Reliability of the system, it depends upon directly proportional to the number of components, rotating component or number of components used in that system. Because failure of any kind of system, it is depending upon the number of part. So more the number of part, the reliability will be less, and lesser the number of part, the reliability will be more. So therefore we can say that electric vehicle are having only 18 moving part compared with the IC engine vehicle, which is having more than 2000 plus moving part. So therefore EVs are 10 to 100 times cheaper to maintain, means it is economical to maintain the vehicle. So therefore the electric vehicle, they can offer us the e-mobility solution for the future transportation and for the sustainable technology. Then if you look at the well-to-wheel analysis, I have tried to plot the well-to-wheel analysis. Under this well-to-wheel analysis, the topmost diagram, which you can see that the well that from fuel extraction is there from the well, then there is a generation of the carbon dioxide from the oil refinery, power generation, there again the carbon dioxide is there. Then fuel to tank, if you see refueling, again the some kind of CO2 generation is there. And then driving a vehicle means right from ऑयल जहां से निकालते हैं रिफाइनरी से, वहां से लेके ऑयल रिफाइनरी से पेट्रोल पंप तक लेके, पेट्रोल पंप से लेके गाड़ी में यूज करने तक के, okay, once you use the petrol or the diesel or the fuel vehicle, in that case there will there will be a emission of the carbon dioxide, carbon monoxide, oxides of nitrogen and the hydrocarbon, which means that entirely IC engine vehicle, it pollutes the environment compared with the electric vehicle. If you see the bottom picture, then okay, the power generation, it is okay, but when it comes to the electric vehicle, till power generation, the 30% efficiency, 80% efficiency, that carbon dioxide is being generated, monoxide is being generated. But when you come to the electric vehicle, the tank to wheel carbon monoxide generation or the carbon dioxide generation, it is being becoming zero. Okay, so if you see again the CO2 emission wise, we can see that yeah, because of the IC engine vehicles, gasoline vehicle, around 11,000 lbs is being generated, carbon dioxide, oxides of nitrogen 6.5 lbs, and particulate matter means गाड़ी के साइलेंसर से जो ब्लैक सूट निकलता है, वो बेसिकली पर्टिकुलेट मैटर है, वो 0.4 एलबीएस में आता है. अभी अगर हम ईवीज इलेक्ट्रिक व्हीकल को ग्रिड के ऊपर चार्ज करते हैं, तो इन दैट केस 11,000 एलबीएस से लेके कार्बन डाइऑक्साइड जनरेशन 4,000 एलबीएस तक आ सकता है. एनओएक्स जो है वो एनऑक्स ऑक्साइड्स ऑफ नाइट्रोजन 2.3 एलबीएस आता है. और particulate matter, particulate matter जो है 0.4 lbs आता है. If we think of, okay, the basically charging the electric vehicle with the help of the non-renewable energy like wind energy, like a solar energy, then in that case the carbon dioxide generation, it comes down to be zero, oxides of nitrogen, it comes down to zero, and particulate matter, it comes down to zero point 0.1. So look at the well to wheel CO2 emissions which is happening here. In this case, CO2, NOx and particulate matter, it is coming out to be zero or the negligible amount when we charge the electric vehicle with the help of the renewable. So therefore, from the air pollution point of view, the electric vehicle, it basically offers the lot of advantages, and it can be a part of the sustainable technology as far as EVs are concerned. If you look at the sneak peek into the history of the this particularly the history of this electric vehicle, okay, we can see that electric vehicle were introduced in the world scenario in 1832 to 1888. Robert Anderson, Thomas Parker developed the electric vehicle initially. In 1889, again, fleet of taxis were introduced. In 1907, again, Detroit Electric debuts in the international market, US market. 1898 to 1901, Ferdinand Porsche builds the world's first hybrid electric car. In 1908, again, mass-produced Model T Ford deals blow to the EVs, and in 1935, again, the electric vehicle, it is disappeared from the market. So electric vehicle disappeared from the market. The reason being is that, okay, we always compare the cost of the fuel prices and how economical it is to run the vehicle. तो इसकी वजह से क्या हो गया कि फ्यूल के प्राइसेस जो है वो काफी कम हो चुके थे 1935 के दरम्यान में. पेट्रोल डीजल जो है वो काफी कम रेट में मिल रहा था. बिकॉज ऑफ दैट अगेन द पीपल हैव शिफ्टेड and to the gasoline vehicle, IC engine vehicle, and again the electric vehicle disappeared from the market. But again, in 1963 to 1979, throughout the world, there is a oil crisis which has compelled us to rethink on our option. And because of that, the 1970 to 1990 CARB introduces the Clean Air Act and zero emission mandate. And again, there is a return of the electric vehicles in the international market by means of the 1991 Corvette, and then 1997 Toyota, then 1999 Honda Insight, 2001 Riva Electric, 2008 Tesla Motors, and 2010 Nissan Leaf. So again, there is a return of the electric vehicle in the India, and this is what the sneak peek into the history. Nowadays, you know that there is a something world war like things are going on. Russia, Ukraine are fighting right now also. The Israel, the issues are there. Because of that, the oil producing countries may not be in a position to provide the oil or provide the fuel to our country, and therefore we have to look for the sustainable technology, or we have to look for alternative options like electric vehicles to use it to replace the basically this gasoline vehicle. If you look at the global sales of electric vehicle, then we can see that Norway 55.9% in 2019, and United States 2.1%. Somewhere in the mid of this one, you can see Finland 4.7%, Ireland 19.1%, and this is by the top three global markets by total EV sales in 2018. तो आपको इस लिस्ट में इंडिया का नाम नहीं दिखेगा. इलेक्ट्रिक व्हीकल के लिस्ट में। इतनी बड़ी लंबी लिस्ट लगाई है मैंने, लेकिन यहाँ पे जो है इंडिया का नाम नहीं दिखेगा, क्योंकि 2018 के सर्वे के हिसाब से इंडिया सोल्ड 3,600 इलेक्ट्रिक कार्स अगेंस्ट 3.6 million cars sold in 2018-19. That is only 0.1%. So in India, EV sales significantly increased in 2024 with a total EV sale exceeding 2 per million unit, and EV penetration is rising, and it is reaching approximately 8% of the total vehicle market. मतलब जहां पे हम 2018 में 0.1% पे थे, इंटरनेशनल सेगमेंट में हम लोग कहीं पे भी पिक्चर में नहीं थे, वहां से स्टार्ट होके 2024 तक हम 8% of the total vehicle market, it is captured by the electric vehicle. So top countries which are basically able to sell the electric cars in 2023: China, United States, Germany, France, and the United Kingdom. These are the top 5 countries. So sale of the electric vehicle in the India has the potential to sell electric vehicle in large number to curb the menaces of the degrading air quality index. All of us are aware that the India has signed a Paris Climate Agreement in 2015, and because of the Paris Climate Agreement, it is mandatory for the India to reduce down the air pollution index, to improve the quality of air index, and improve the quality of the air. Therefore, it is mandatory on part of us to reduce down the pollution, air pollution. And because of the gasoline vehicle, the lot of air pollution is there. You are aware that the in the state of Delhi, the chief minister has introduced the formula like odd even formula, जैसे कि odd number की vehicle मंडे को चलेगी, या even number की vehicle ट्यूसडे को चलेगी. इस तरह का फार्मूला इंट्रोड्यूस किया था. इन स्पाइट ऑफ ऑल अवर एफर्ट्स, we are unable to control the pollution in the capital place of the India, that is Delhi, and air quality index, it is degrading day by day. Therefore, the government of India has come up with the roadmap for the electric vehicles in the India, and India may beat United States in electric vehicle sales in next 20 years from now. So, which means that in future by 2030, the plan of the government of India is to introduce the entire segment of the vehicle as a electric vehicle. This is the growth of the sale of electric vehicles in 2024. We can see that Tata, then MG Hector, Mahindra, Hyundai, BYD, BMW, even Mercedes, Volvo, Citroen, Audi, Porsche. So almost all kind of brands which are being available in the international market, those who are producing the gasoline vehicle, they have started introducing their own vehicles which are in the EV segment, like a Tata Tiago, Tata Tigor, then Comet, then Hyundai Kona, Iconic. Likewise, the many more EVs offer are there, and the price range also, it is in almost in all kind of price ranges. EVs are being available, electric vehicles are being available, and the manufacturers also, they are promoting the use of the electric vehicle in line with the vision of the government of India and the government of Maharashtra. Okay, and this is the development about the India's goal for electrification, that National Electric Mobility Mission Plan, which basically looks for the sale of the 6 million electric vehicle, then FAME India, faster adoption and manufacturing and electric vehicles in India by the Niti Aayog. Then Energy Efficiency Service Limited has floated tenders of the around four-wheeler electric vehicles and procured 10,000 vehicles from Tata Motors, Mahindra. So there is a growth of the electric vehicle in the share mobility sector. Shared mobility means where the public transportation is there, like Ola, Uber, Ather Energy, Blue Smart. So there is a particularly growth is being seen in the shared mobility sector. Therefore, the government of India has introduced the under the National Electric Mobility Mission Plan 2020-20, the FAME scheme. So FAME scheme is nothing but the faster adoption and manufacturing of hybrid and electric vehicles in India. And this FAME scheme has a four potential areas which is being highlighted in the FAME scheme. First thing is that technological development. So technological development means as far as the EVs are being concerned, the technology is not yet matured, and this technology has to go a lot of lot like budding engineers, the future engineers, the researchers, those who are working in this particular area, they need to focus on developing the electric vehicle area so that the cost of the electric vehicle can come down and down. The second thing is that demand creation. So at this juncture of time, let me congratulate the PS College of Engineering, Chhatrapati Sambhajinagar, for taking the initiative to match with the vision of the government of India regarding the demand creation. In demand creation, what we are looking for, creating the awareness among the people for an electric vehicle. Unless and until awareness is created, the people will not use the electric vehicle. So therefore, creating awareness, creating a demand for the product is being required. So PS College of Engineering, in line with the mission of the vision of the government of India, they are creating the awareness by arranging the such type of lectures on the electric vehicle. Then the third thing is regarding the pilot project. So under this FAME scheme, the pilot project has been introduced, and some pilot studies are being carried out so that whatever the drawbacks are there, these drawbacks are being removed from the EV electric vehicle, and these drawbacks can take up shape to improve upon the electric vehicle. And the charging infrastructure, the charging infrastructure is not there at present in India, but you know that there are around 85,000 to 86,000 petrol pump station, fuel pump station in India. If we go by even by the Samruddhi Mahamarga to the Nagpur to Chhatrapati Sambhajinagar, at few places you will find the fuel pump station. Similarly, by normal road also, if you travel to Chhatrapati Sambhajinagar to Nagpur, you will find so many, several petrol pump station, fuel pump station in India or in Maharashtra and on that particular route. But if you hire or if you purchase your EV, then naturally charging infrastructure is to be built up at this petrol pump station or separately on the route. So therefore, the FAME scheme of Government of India is focusing on developing a charging infrastructure, and charging infrastructure it is also getting developed. So Niti Aayog report, which talks about the approach to the mobility transformation, it is said that India can save 64% of the anticipated road-based mobility related energy demand and 37% of the carbon emission in 2030 by pursuing a shared electric and connected mobility, resulting in a net saving of roughly 3.9 lakhs crores of rupees, approximately $60 billion US dollars in 2030, which means that if we go with the same pace and if we are using the electric vehicles in India, naturally lot of foreign investment, because only 20 to 25% of the fuel is being produced in India. Rest 70 to 75% of the fuel it is being imported to India from the US countries or from the Russia. अभी आप लोगों को जानते ही होंगे कि भाई अमेरिका के प्रेसिडेंट डोनाल्ड ट्रंप अपोजिशन में है या अपोज कर रहे हैं, इसीलिए ये हम लोग रशिया से फ्यूल खरीदते हैं है ना, उनकी जो ऑपरेटेड वेल है उनसे नहीं खरीदते हैं, वो कंट्री से नहीं खरीदते हैं। तो इसलिए ऐसा है कि ट्रेड वॉर इज गोइंग ऑन और टैरिफ वॉर इज बीइंग गोइंग ऑन in the international segment, and we are spending a lot of money in procuring the vehicle, procuring the fuel to the India. So if the India tries to develop our own technology, indigenous technology of electric vehicle, डेफिनेटली हमारा जो डिपेंडेंस है फ्यूल के लिए, वो डिपेंडेंस हमारा अदर कंट्रीज के ऊपर कम हो जाएगा। So what are the growth drivers of the electric vehicle? There are six factors which are basically responsible for the growth of the electric vehicle, like environment, then politics, then economy, then technology, then society, and the infrastructure. So if you look at the environment, then you will find that climate change, it is being happening. Reduction of global CO2 emissions is there. If you look at the politics, then the international specification for emission limits, introduction of the low emission or emission free zone, and we have talked about, we have already signed a Paris Climate Agreement. Then limited oil reservoirs under the economy, rising prices for fossil fuel. आज पेट्रोल और डीजल के दाम जो है 100 रुपीज के ऊपर चले गए। सो नेचुरली इकोनॉमिक फैक्टर्स आर टू बी कंसिडर्ड। technological advantages of electric motor compared with the internal combustion engine, for a society also, growing mobility, increasing acceptance toward the electromobility. In infrastructure, comprehensive infrastructure to supply energy for electric vehicle at home, at work, on the route. So these are all six factors. These are the growth drivers for the growth of the electric vehicles in the India. The scenario of electric vehicle in India, Indian government is now racing to switch to all electric cars by 2030. It is already being planned and it is already being informed to all the concerned that in India by 2030, all the cars will be electric cars. Indian government has set an ambitious target that 100% of the EVs for public transport, 40% of the electric for personal mobility by 2030. Then what are the generic points for the Indian automobile sector or Indian automobile user? Price of the vehicle, the most dominant need for most non-premium market segment. So price of the vehicle at present comparatively it is higher than the gasoline vehicle. Therefore, the government of India has introduced the subsidy of 2.5 lakhs for purchasing of the electric vehicle, wherein you can derive 2.5 lakhs benefit for purchasing of the electric vehicle. Then running cost, the second most dominant need for the most consumer mass market segment. Performance and important need for premium segment. Then cool factor, important only for the premium segment. So these are the generic needs for an Indian automobile user. Factors which basically driving the electrical mobility in India, I have tried to plot it into the various segment: two-wheeler, three-wheeler, uh, then passenger vehicle, then commercial vehicle, and 3 points are being considered like a favorable, neutral, and the unfavorable. So if you look at the basically the two-wheelers, route predictability is a neutral, vehicle utilization neutral, and the policy intervention potential it is unfavorable. So these are the basically the growth factor for a light motor vehicle, for a heavy segment. It is being plotted, and what we can see that under the three-wheeler or under the two-wheeler or the large commercial vehicle, the favorable situations are at many of the places, the favorable situations are being arising. And because of this favorable situation, there is a growth of the electric vehicle which is seen in the India. Initial developments of the electric vehicles in the India, the first electric three-wheeler was developed by the Scooters India Limited in Lucknow in 1996, and approximately 400 vehicles were made and sold. Mahindra and Mahindra, they launched its first electric three-wheeler in 1999, including a new company named MEML, based in Coimbatore in 2001. Then Bajaj Auto Limited also they have demonstrated their three-wheeler, three-seater electric rickshaw in 2001. Riva Electric Car Company, they also introduced the first electric car, Riva in India by the 2000. So this is the current market sizes of electric vehicles in India. If you look from 2001 to 2020, we can see that Riva Electric, Mahindra E20, BMW i8 to the heavy vehicle segment like Tata Starbus Ultra Electric introduced in 2018. Then in 2020, JBM Solaris Ecolite. So even from the Ashok Leyland, Mahindra, and BYD, Tata Starbus, almost all kind of automobile manufacturing companies, they are being manufacturing the electric vehicle in all segments. All segments means two-wheeler, four-wheeler, or the basically the buses, trucks, and you will find that the on the road there are various kinds of electric vehicle which are being moving. So this is the journey of the one of the pioneer of the electric vehicle, that is Mahindra. In 1999, they have launched the first electric vehicle, which was the eight-seater electric vehicle, which was titled as the Bijli. So journey of Mahindra and Mahindra automobile manufacturer. It has been started from 1999, and if you look at till 2018, launch of the Trio Auto Showcase and many more things, many more model electric vehicle model, they were introduced by the Mahindra in the Indian segment and in the international segment. India market scenario, electric vehicle, if we compare with the four regions of the India like East Zone, West Zone, South Zone, and the North Zone. Okay, then region wise also it is being plotted, wherein in the northern zone, the sale of the electric vehicle, it is around to 40.3%, and in the eastern part of the country, it is around 8.53 to 8.40%. So north region accounted for over 40% of the volume share in electric vehicle market in India, and is expected to remain dominant during the next 5 years on the back of the factors which are there, that is growing road congestion, rising development in public transport, high urbanization, high vehicular air pollution. If we try to plot the strength, weaknesses, opportunities, that is SWOT analysis for an electric vehicle, I will not consider all the factors, but I will discuss the few factors here regarding the SWOT analysis. Like a strength is low running cost, it is economical to maintain, and the low running cost is there. Weakness is high initial price compared to the gasoline vehicle. Currently, it is around means 2.5 lakhs higher than the gasoline vehicle. Opportunities, more opportunity for the R&D is there. Okay, because now it is recently vehicles, electric vehicle technology which is being introduced, and we have to see that the many more things are to be developed, and we don't have the resources, raw material to make up a battery. Basically, lithium ion battery जो यूज की जाती है, तो अभी अपने पास माइनिंग के सोर्सेस नहीं है, तो हमें देखना पड़ेगा कि लो कॉस्ट मटेरियल इट इज बीइंग डेवलप प्रोक्योर्ड टू इंडिया, एंड वी कैन हैव द मोर एंड मोर research opportunities here. Then threats, different manufacturer may have different charging plug. This is the threat because गाड़ी के टैंक में पेट्रोल पंप पे, कोई भी पेट्रोल पंप पे अगर पेट्रोल भरा तो वन एंड द सेम थिंग होता है, स्पेसिफिक ग्रेविटी सेम होती है। लेकिन यहाँ पे अगर चार्जिंग प्लग अगर डिपेंडेंट होता है मैन्युफैक्चरर के ऊपर, तो एक आधे चार्जिंग प्लग के आपकी गाड़ी चार्ज नहीं हो सकती है। So the different manufacturers may have the different charging plug. So this kind of possibility is there. Then if you look at the increasing amount of research and development, that is a strength. Lack of spare part in case of repair and maintenance, this can be a weakness. Then opportunities encourage consumer buyers with trained salesperson at dealer shops. The lack of compaction leads to the lack of design. Declining petrol and diesel prices can reduce the EV sales. So this is the SWOT analysis. If you look at the world policy, then every country, like a Norway, to phase out fossil fuel by 2025, and we have seen that around 50% of the vehicle share in Norway, it is because of the electric vehicle. In France, Italy, UK, Sweden plan to stop sales of fossil fuel car by 2040. China has also given an indication that it will ban sale of IC engine vehicle. 90% of the vehicles sold in USA would be electric by early 2040. Indian government also to lead the change by inducting 10K EVs, 10,000 EVs to be used by different departments. So what we can see that the overall in nutshell throughout the world the development of electric vehicle is being going on, is being planned, and the electric vehicles are most importantly are playing the role in case of the each of the countries segment. So now if you look at the key objectives of the EV policy which is framed by the government of India, one one of the important factor is to reduce the primary oil consumption in transportation, facilitate customer adoption of electric and clean energy vehicle, reduce pollution in the cities because our cities are become getting polluted, create EV manufacturing capacity that is of global scale and competitiveness, facilitate employment growth in a sunrise sector, encourage cutting edge technology in India through adoption, adaptation and research and the development. So this is the electric vehicle policy action plan that by 2019 scheme of faster adoption and manufacturing of electric vehicle in India to phase out. Okay. National mission plan of electric mission. So let me check once again whether I am audible or not, whether my screen is visible to you or not.
Yes, sir. It is visible. You are audible.
Okay, thank you. Huh. So innovation through the any MMP 2020-20, any MMP also targets 4 lakh passenger battery electric vehicle by 2020, avoiding around 120 million barrels of oil and 4 million tons of the CO2. There is a policy for facilitating the research and development, manufacturing policies, then permissive legislations are there. A National Electric Mobility Plan 2020 targets to deploy 5 to 7 million electric vehicles in the country by 2020. So these are the innovations. Faster adoption FAME scheme, basically it is a implemented from since 2000 April 2015 and extended up to 2019. It has an outlay of around 750 millions of the Indian rupees. Means that kind of infrastructure development is being going on through the government of India. if we look at the electric vehicle policy overview, then Honorable Minister Nitinji Gadkari, who is from the Nagpur only, Highway and Transport Ministry he is heading, and you are aware that he has pushed the automotive manufacturers to make EV plans executable, and there are certain basically benefits of the GST also offered from the government of India, that 5% of the GST for the electric vehicle, and various states also they have their own EV policy. Similarly, recently the government of Maharashtra has also launched its EV policy. Okay, इलेक्ट्रिक वाहन धोरण आखलेले आहे महाराष्ट्राने, आणि त्यामध्ये इलेक्ट्रिक व्हेकलचं प्रमोशन केल्या जात आहे, आणि इलेक्ट्रिक व्हेकलसाठी लागणारा जीएसटी आहे किंवा सबसिडाइज रेट आहे किंवा किंवा नागपूर टू छत्रपती संभाजीनगर जर आपल्याला समृद्धी महामार्गाने जर जायचं असेल तर त्यामध्ये आपल्याला टोल टॅक्स सुद्धा इलेक्ट्रिक व्हेकल साठी माफ करण्यात आलेला आहे. सो दिस काइंड ऑफ electric vehicle, if you purchase electric vehicle, this kind of benefits are being floated and offered by the government of India and the Maharashtra government. The next scheme which is being going on, which is being implemented, is basically the FAME scheme 2, part 2, phase 2. Under this FAME scheme, the demand incentives, okay, the charging infrastructure, the administrative area, administrative setup. So each of the thing means the targeted and total funds requirement, like a FAME2 scheme, 9,634 Indian rupees, crores of rupees are to be invested. So this is what demand incentive based on battery energy content, charging infrastructure, and the last picture you can see that which is being taken up by the PS College of Engineering, that is information, education, and communication. So there basically the topic suits to the vision of the government of India, like creating a demand, creating awareness, informing the society about the electric vehicle, and educating the people and communicating with the people. Okay. Government initiative for electric vehicle state-wise, you can see that under FAME2 scheme, the charging station which are sanctioned under the FAME2 scheme. If we look at our state, Maharashtra state, around 317 charging stations are being sanctioned. Okay, in the Maharashtra state. In Uttar Pradesh, 207. Someone was from the Karnataka. So if we look at the Tamil Nadu, Andhra Pradesh, Karnataka, 172 charging infrastructure is being sanctioned. But I know that this much charging infrastructure is not sufficient to have in the country, and lot of development has to take place. Okay. This is the startups and the general awareness in India, that there are many more startups are there who are making EVs in the India today, like Revolt, Ather, under the Startup India, Make in India, or Skill India, or the Digital India initiatives of the government of India. These are the 5 representative startup of EV motorcycles in the two-wheeler segment, like Torque Motor, Kapil Sherke, Ankit Bhatti, and Bhavish Agrawal, Lux Motor, Varun Mittal, Ather Energy, Tarun Mehta, Ultraviolet Automotive, Narayan S, and Neeraj R from the TVS Motor. Rahul Sharma, the person who has manufactured the mobile phone Micromax, he is into the Revolt Intellicorp as a startup of the two-wheelers in the India. These are the other startups which are and the general awareness in India. Garage Plug is there, Sun Mobility, Tanwal e-vehicle, Zen Drive. Okay, so these are all the other startups in India. categories of the electric vehicles in the India. In the electric vehicle, almost all kind of electric vehicles are being manufactured. Like a two-wheeler is there, e-rickshaw is there, four-wheeler means passenger vehicle is there, M1, N1 category, heavy vehicle is there, M2, M3 category, e-auto, electric two-wheeler. So in the under the all type of segments of the electric vehicle is there. What is innovation expected is basically the measurement of electric energy consumption, हाउ टू मेजर द इलेक्ट्रिक व्हीकल कंजम्पशन, क्योंकि हर एक कंट्री में हर एक स्टेट में इलेक्ट्रिसिटी के टैरिफ अलग अलग है। दिल्ली में लोग बोलते हैं ये इलेक्ट्रिसिटी बहुत चीप मिलती है, और महाराष्ट्र स्टेट में 14 रुपीज पर यूनिट मिलती है, या कुछ अलग हो सकता है। ठीक है, कर्नाटका तमिलनाडु में अलग अलग इलेक्ट्रिसिटी का टैरिफ हो सकता है। तो गाड़ी अगर व्हीकल लेके जाते हैं तो उसका मेजरमेंट ऑफ इलेक्ट्रिक कंजम्पशन किस तरह से करेंगे, या उसको किस तरह से नॉर्मलाइज करेंगे, ये भी एक उसमें इनोवेशन एक्सपेक्टेड है। Okay. Yeah, the key areas basically which includes like a battery technology. Okay, there are various types of battery technology like solid state batteries, lithium sulfur batteries, battery recycling technology. Even in the charging infrastructure, the ultra fast charging, wireless charging, vehicle to grid integration, V2G integration. So lot many things are being possible, एंड वी नो दैट कि अगर हम लोग गैसोलीन व्हीकल लेके जाते हैं तो हम लोग 5 मिनट 10 मिनट से ज्यादा वेट नहीं करना चाहते हैं पेट्रोल पंप स्टेशन पे, और जल्दी से जल्दी हम लोग जो है फ्यूल भर के वहां से निकल जाना चाहते हैं। तो वहां पे जो है, तो बैटरी में अगर चार्जिंग में समय लगता है, अभी आधा घंटा लगता है या 1 घंटा लगता है, सो नोबडी इज गोइंग टू going for the basically going to wait for getting our electric vehicles charged. So therefore we have to think of having ultra fast charging technology. This technology will significantly reduce charging time, addressing range and safety. So that is being targeted. The various types of the electric vehicle which are and presently available, like battery electric vehicle, hybrid electric vehicle, plug-in hybrid vehicle, and the fuel cell electric vehicle are available in the market. Okay, battery electric vehicle means vehicle that uses electrical energy to drive and store this energy in batteries. Hybrid electric vehicle, they are powered by an internal combustion engine and one or more electric motors which uses energy stored in batteries. Fuel cell electric vehicle are powered by hydrogen. They are most efficient than conventional internal combustion engine. And plug-in hybrid electric vehicle use batteries to power an electric motor as well as another fuel such as gasoline or diesel to power an internal combustion engine or other propulsion source. So PHVs can charge their batteries through charging in equipment and regenerative braking. So this is the conventionally the structure of an electric vehicle, which consists of battery, DC-AC converter, controller, electric motor, GB module, wheels. This is basically the battery electric vehicle structure. You can see that traction battery, traction motor, inverter. Okay. So key components of an electric vehicle, the particularly the key components, electric source, the battery is there, then electronics control, and the electric machines. So these are the key components of an electric vehicle. The now there is no need of the gearing mechanism in the sense गियर बॉक्स या गियरिंग मैकेनिज्म यहाँ पे नहीं लगेगी, क्योंकि इलेक्ट्रिक व्हीकल में जैसे जैसे आप एक्सीलेटर पे बढ़ाओगे उसी तरह से उसकी स्पीड बढ़ती जाएगी। तो जैसे एक्सीलेटर कम करोगे स्पीड कम हो जाएगी, तो इसलिए गियरिंग मैकेनिज्म नहीं रहेंगे। ट्रांसमिशन सिस्टम भी जो है अलग तरह का रहेगा। और यहाँ पे इंजन अगर नहीं है इलेक्ट्रिक व्हीकल में, तो काफी स्पेस आपकी बच जाती है। इलेक्ट्रिक व्हीकल में बैटरीज को प्लेस किया जाता है नीचे की साइड में, बॉटम की साइड। तो इस तरह का एक कॉन्फ़िगरेशन रहता है। एंड डिपेंडिंग अपॉन द डिग्री ऑफ हाइब्रिडाइजेशन, जैसे कि उसमें अलग अलग सेगमेंट हैं, लाइक माइक्रो, माइल्ड, मीडियम, फुल पावर एंड द प्लग इन, डिपेंडिंग अपॉन दैट. So this is the product development, which we call it as a V model, like detailed design and optimization, subsystem design, system functional and architecture design, then requirements and the specification. So V model is emerging as one of the widely used development processes in the automotive industry. This model splits the development process into two parts, that is verification and the validation. Because system validation, requirement specification, it has to be validated. Okay. If we sneak peek into the history of the batteries, then we know that first motors in 1800 century were introduced DC powered by poor batteries, and the lead acid battery was invented in 1859, and in 1980 the American physicist Professor John Goodenough, he has invented a new type of lithium battery in which the lithium ion could migrate through the battery from one electrode to the other as a lithium ion. And he now invents a glass battery which is a three times better. So Nobel laureate was given to the John Goodenough. He has honored with the Nobel laureate, and the lithium ion batteries now is taking the shape of the every electric vehicle, and it is being used. These are the various types of batteries typically used in the electric and hybrid electric vehicle, like lead acid batteries, lithium ion batteries, NiMH batteries, or the metal air batteries. This is the various form factors of lithium ion batteries, like it comes in the cylindrical cell, it comes in the pouch cell, prismatic cell. Okay, so these are the various modules as well as the shapes of the batteries. So battery pack or batteries are being used. Several batteries are being used in the electric vehicle with a different configuration. Battery module means module is a group of physically or electrically connected cell. Module can be thought of as the smallest repeating building block of a battery pack. So these are the battery pack. On your screen, you will be able to see the basically the battery packs. Then types of battery material, batteries are classified based on the electrochemistry. So most common are lithium, lead, and nickel base. So you can see the specific energy versus specific power it is having. So lithium ion, metal potential, it can run for a longer time compared with the conventionally invented lead acid batteries. Now, while discussing the basically the resources available for battery material, what we have seen that in India it is not available. We have to look for lithium is available in mining resources are available in the Australia. Okay, in the Peru, China, the copper is being available, and cobalt, nickel is being available. So we are again the if you see the percentage of global extraction or refining, we do not stand in the international market. We have to be dependent for procuring the raw material which is required for the manufacturing of the batteries from the countries like Australia, from countries like China, Peru, Chile, and Philippines, Indonesia, like that. So these are the types of charging station used in electric and the plug-in hybrid electric vehicle. Various types of charging stations are being used. Okay. Now I will switch to the last part of my presentation, that we are working on a electric vehicle, and our honorable secretary that time, the Shri Rastogi sir, he has given us one project, and he has asked the automobile engineering department of Government Polytechnic Nagpur of my institute, in which I am heading the automobile engineering department. He asked me to basically to look for the retrofitting of the electric vehicle. So one of the old vehicle which was available at our institute, it was retrofitted, and we are the first in the Maharashtra state. The automobile engineering department is the first in the Maharashtra state to launch the course on the electric vehicle. है ना, हमारा जो कॉलेज है या डिपार्टमेंट है, उसकी स्थापना हुई है 1914 में, 1914, like you people. Your education society also initiated by the Bharat Ratna Dr. Baba Sahib Ambedkar. So similarly, one of the oldest education society in the entire country. Similarly, the Britishers, they have started with the School of Engineering in 1914. मतलब आजादी मिलने के काफी पहले 1914 में इसकी स्थापना हुई थी, और वी यूज टू रन अ कोर्स ऑफ 1 year course on the automotive vehicle, and this course run by us, offered by us, now it is being transferred into the electric vehicle course, 1 year electric vehicle course. So therefore we have retrofitted some vehicle, Tata Motors vehicle, as a electric vehicle, या इंजन निकाल के उसका retrofitting किया है, and you can see our students also working on this project. And the news was flashed into the leading newspaper of the Maharashtra state, English daily, that is Hitwa. So the concerns about the electric vehicle, हम लोग लॉन्च तो कर रहे हैं, लेकिन जो कंसर्न्स है अभी भी, जिसके हमें सॉल्यूशंस निकालना है, वो कंसर्न्स है इलेक्ट्रिक व्हीकल सेफ्टी। ओके, सर्कल ऑफ सेफ्टी। तो एक केस में आप देख रहे हैं कि अगर एक्सीडेंट हो जाता है, तो अगर इलेक्ट्रिक व्हीकल में एक्सीडेंट हो जाता है, तो देर आर चांसेस ऑफ गेटिंग द फायर, और द व्हीकल कैन कैच अ फायर बिकॉज इट कंसिस्ट ऑफ द बैटरीज। अगर फ्रंटल एरिया में बैटरीज को लोकेशन करते हैं, तो नेचुरली चांसेस ज्यादा रहते हैं, इसलिए बॉटम साइड में करते हैं। अब बॉटम साइड में करते हैं तो भी दूसरा हमारा प्रॉब्लम ये है कि क्लाइमेट चेंज की वजह से कभी भी सडन बारिश, ओके, या क्लाउड बर्स्ट होने की वजह से सडन बारिश आ जाती है, तो फिर से शॉर्ट सर्किट या फिर बैटरीज में प्रॉब्लम आ सकता है। So safety also we have to ensure, like a gasoline vehicle जैसे safe रहते हैं, उसको it does not catches a fire. Similarly, we have to look for this kind of EV regulations in the India. Okay. Now the skill map which is being required, because all of your teacher, professor in the engineering colleges or polytechnics throughout the India, and now we are looking for a entirely new skill or skill map development. If the EVs are being launched, then what will be the summary of the skill requirement? The entirely new skills are being required as a mechanical, as a electrical engineer. Entirely new skills are required from the students, like battery pack assembly, manufacturing of charging infrastructure. Okay, then the reskilling from the automotive sector, uh, So that reskilling from the automotive sector, like testing and validation of the EVs, charging infrastructure, then mechanical structure assembly, new skills from other sectors are being required other than automotive, that is high voltage handling, expertise from safety, developing apps for GPS system, billing system, expertise from the power electronics, and skills which are totally to be removed from the automotive sector, that is low requirement of emission expertise. Since the electric vehicles are being launched, are being introduced, there will be a no expertise required from the emissions point of view. Reduction of skill requirement in IC engines, then petrol gas station attendant to be replaced by charging swapping station operator. Means mechanic, engineer, uh, technicians, after sales technician. They need to have this kind of new skills when the EVs are being launched fully. And nowadays, EVs are being available in the market in the Indian segment, lot of EVs are being available. So we have to see that our students are being developed with the new skills which is required by the India. Those who are autonomous institution, they need to adopt the curriculum of electric vehicle, and they need to have the electric vehicles in the that kind of skill map is being required. Okay. Hello, sir. नमस्कार. मी एक लेक्चर घेत आहो. मी थोड्या वेळाने फोन करतो मग, है ना? ओके. So petrol gas station attendant to be replaced by charging swapping station operator. So this kind of new skills are being required in case of the electric vehicle. Baha competition is there. AC India has launched the Baha competition in the electric vehicle also. Your students might be participating and preparing their own vehicle to participate in the Baha competition, which is very popular, which is launched by the AC India throughout India, and the students from the various countries, they are participating in this competition. Okay. There are certain skill development programs which is being going on, and awareness is created, that is a postgraduate diploma in electric mobility which is available at the COP Pune, Tamis College of Engineering, Women, Pune. They have launched again this kind of course. Savitribai Phule Pune University is having. Okay. Then Maratha Chamber of Commerce, Industries and Agriculture, Automotive Research Association of India, ARAI Pune, they also offers the such kind of postgraduate diploma in electric mobility. Similarly, 1 year full-time postgraduate diploma in electric mobility is launched by the Government Polytechnic Nagpur Automobile Engineering Department. This is a part-time diploma in electric vehicle at GP Nagpur, and we have conducted the 2 batches wherein the engineers from the nearby society, technicians from the nearby society, after sales technician, okay, mechanic, and senior supervisor, they have attended this kind of 1 year part-time diploma in electric vehicle at GP Nagpur. So we are also in line with the Government of India's mission, creating awareness, also offering the skill enhancement courses in the electric mobility. Other than the 3 years diploma course, जिसमें 10वीं 12वीं के बच्चे आके पढ़ते हैं, AICT का डिप्लोमा कोर्स, उसके अलग से हमने उसके अलावा हमने अपना एक इलेक्ट्रिक व्हीकल का कोर्स लॉन्च किया. Okay. Then this is FEM 1, FEM 2 scheme. Okay. I should reserve some time for the discussion also. Therefore, I am going through the now the Maharashtra State Policy 2018 Vision Transforming Maharashtra into a globally competitive state for electric vehicle and component. Objective is to develop Maharashtra as the leader in EV manufacturing and use to create newer employment opportunity, create jobs for 1 lakh people. और इसी के चलते रिसेंटली प्रसार भारती आकाशवाणी नागपुर जो कि गवर्नमेंट का एक रेडियो है, मतलब रेडियो चैनल है, आकाशवाणी नागपुर के ऊपर मुझे इंटरव्यू के लिए बुलाया गया था। और फोर्थ टाइम ये आकाशवाणी नागपुर पे इंटरव्यू था। और महाराष्ट्र गवर्नमेंट की क्या पॉलिसी है ईवी के बारे में या इलेक्ट्रिक व्हीकल के बारे में, क्या डेवलपमेंट थ्रू आउट द वर्ल्ड हो रही है, इसके बारे में मेरा इंटरव्यू ब्रॉडकास्ट किया गया था। और एक महीने पहले करीबन ये इंटरव्यू आया था। ये नेट पे या कहीं पे या रेडियो चैनल पे आकाशवाणी के ये अवेलेबल हो सकता है। आप भी सुनिए उस इंटरव्यू को कि किस तरह से इलेक्ट्रिक व्हीकल जो है डेवलप होते जा रहे हैं हमारे इंडिया में, हमारे महाराष्ट्र में, और किस तरह से क्या पॉलिसीज है। ओके, these are the business model of e-rickshaws in the New Delhi. Cycle rickshaws, auto rickshaws, electric rickshaws, almost in every city you will find an electric vehicle. This is the smart city pilot project in my city, in Nagpur city. Now we will take up the how the pilot city project is being developed. Like vehicles deployed, around 200 EVs are deployed in the Nagpur city. Charging infrastructure, battery swapping stations are developed for the 3Vs, okay, three-wheeler, means auto rickshaws and all. Single point multiple charger, all EVs come back to base of the charging. 100 car, 100 e-rickshaws, 2-3 buses. This is the smart city pilot project of Nagpur city, wherein Mahindra E20 plus hatchback with an average daily run of 142 kilometer are being launched in the smart city project. Kinetic Safar e-rickshaws are launched in Nagpur city, which is having a battery capacity of 2.8 kWh, passenger capacity 4, and average daily run of 66 kilometer. Okay. Under the smart city project of Government of India, 3 charging stations are being developed in Nagpur Airport. At Nagpur Airport, IOCL Indian Oil Corporation Limited fuel station, and in Nandanvan. Nandanvan is one of the area in Nagpur wherein the 5 fast charger, 5 slow chargers, and at airport 4 fast and 4 slow chargers are being installed. The charging infrastructure is being developed under the smart city. Okay, operating cost, charging infrastructure, these are the pinpoints and all. Current happenings in the area of electric vehicle. At the end of the lecture, I would like to see that any other smart city project which is being developed in the Karnataka, Tamil Nadu, Uttar Pradesh, from the participants of this FDP, I would like to know that what is the development which is being happening in their state regarding the electric vehicle under the smart city project. So Bajaj Auto launch the Chetak electric scooter. Tesla Motor shows interest in India's plan to build a battery plants under FAME scheme. Tata Motors to supply 500 EVs. So almost each of the government of India's plan is being fulfilled, and each of the manufacturer is manufacturing the electric vehicles in India and trying to develop the global EV market. So finally, we will conclude that the government support and policies is there. So government of India, government of each state government is actively promoting EV adoption through various policies. Growing market and sales is there. We have seen that EV sales is increasing day by day. Infrastructure development, I told you that there are around 80,000 petrol pump station in the India, and only 30 to 40% of the petrol pump station have an electric vehicle charging infrastructure. So it has to come up. यहाँ से अगर मैं चेन्नई जाता हूँ गाड़ी ड्राइव करके या हैदराबाद जाता हूँ, तो उस तरह का चार्जिंग इंफ्रास्ट्रक्चर अभी फिलहाल अवेलेबल नहीं है। लेकिन आने वाले दिनों में by 2030 we will have it. Technological advancement, ongoing advancement in battery technology is being going on, particularly on the cost reduction, so that it will be economical, and cost of the vehicle will come down. Environment benefits are there. EVs offer a significant environment benefit, and the only sustainable technology to reduce our air pollution and to improve the air quality index is EVs only. Economic opportunity. EV sector has the potential to create numerous jobs in manufacturing, battery technology, charging infrastructure development. Challenges which remains with us, that is the affordability, charging infrastructure, and the range of the electric vehicle. Future outlook with continued government support, technological advancement, addressing the global challenges. India is poised to become a major player in the global EV market. So you budding engineers, you are creating awareness among the budding engineers, electrical, mechanical, or the civil engineers, and the faculty member, the professors, those who are attending this particular FDP, faculty development program, will in turn create awareness of EVs among their students. And finally, the day will come when the India will become a major player in the global EV market. So thank you very much. Thanks a lot. Mechanical engineering gears are being shown here. That is industry, student, and academia. Three core elements of an society. And these gears will work only when they are meshed with each other. So this is the only the if we join the hands together, then only the transforming the landscape will be possible. So this is about the electric vehicle for a sustainable technology from my side. Okay, let me take up few questions if any questions are there, and then we will end the lecture. Thank you very much. Thanks a lot. Thanks to the organizer for giving me the opportunity to share my views on the electric vehicle as well as on the sustainable technology by providing me the two sessions in the faculty development program organized by the PS College of Engineering, Chhatrapati Sambhajinagar. Over to organizers, and if any questions are there, let me take the questions now.
Thank you, sir. Thank you very much.
Thank you.
Participant, any question? There is a question in chat box, sir.
Okay.
Mr. Jitendra has asked one question. Battery performance deteriorates with time. What is recommended solution to get consistent performance? Battery replacement cost too much high. So high.
Yes, yes. Yes, Jitendra Balkiwal ji, that is true that battery replacement cost is so high. For one of such conference and interaction during the government agency, I had been to Delhi, and I was interacting with few of the auto rickshaws, and interacting about particularly the electric vehicle auto rickshaws, and they were also saying that कि बैटरी परफॉर्मेंस डिटोरेट हो जाता है। तो हम लोग 3 साल के बाद में, 4 साल के बाद में, जिस ऑटो रिक्शा में मैं सफर कर रहा था दिल्ली में, उसने बताया कि 80,000 रुपये बैटरी की कॉस्ट है। तो सर हम 3-3 साल बाद, 4-4 साल बाद जो है वो बैटरी का कॉस्ट रिप्लेस करेंगे, बैटरीज रिप्लेस करेंगे, तो कैसे चलेगा? ओके, बिकॉज आईसी इंजन जो है उसका लाइफ 5 साल का विदाउट मेंटेनेंस है, और 15 साल का जो है उसका लाइफ है, टोटल लाइफ है। इसलिए गाड़ी का रजिस्ट्रेशन जो दिया जाता है वो 15 साल के लिए आरटीओ के पास में गाड़ी का रजिस्ट्रेशन होता है। उसके बाद में अगर यूज करना है तो 1 ईयर का रजिस्ट्रेशन आपको मिलता है। तो ये हमें बैटरी परफॉर्मेंस के लिए कुछ ना कुछ सोल्यूशन, आप जैसे जितेंद्र जी जैसे जो रिसर्चर है उनसे ये सोल्यूशन निकालना पड़ेगा। और बैटरी रिप्लेसमेंट कॉस्ट इज करंटली इट इज टू हाई। सो इसको हमें सोल्यूशन निकालना पड़ेगा, बट डेफिनेटली विद इन स्पैन ऑफ टाइम और विद द रिसर्च which is being going upon, we will find out the solutions to the battery performance which get deteriorates with the time. So currently जो है वो है, ठीक है, लेकिन आने वाले दिनों में some kind of research which will be focused in this particular area to reduce down or to improve the battery performance, and it should not deteriorate with the time. I hope I have answered your question. Any other question?
हाँ सर, मयूर बात कर रहा हूँ बीआईटी बल्लारपुर से।
हाँ बोलो मयूर।
सर, जैसे कि ईवी चार्जिंग स्टेशन जो होते हैं, अगर
हाँ
वहाँ जो इलेक्ट्रिसिटी यूज हो रही है वो अगर कोल
हाँ,
बेस्ड पावर प्लांट से आ रही है तो फायदा क्या होगा? ये पहला
नहीं,
क्वेश्चन।
इसीलिए इसीलिए मैंने वेल टू व्हील एनालिसिस बताया था। तो वेल टू व्हील एनालिसिस में ईवी मान लीजिए कि कोल बेस्ड पावर प्लांट से पावर आता है, तो वेल टू व्हील एनालिसिस में जब तक वो गाड़ी में जाता नहीं है पावर, तब तक के वो मतलब कार्बन डाइऑक्साइड का एमिशन होगा ही होगा। ओके, लेकिन अगर इलेक्ट्रिक व्हीकल यूज करते हैं तो वेल टू व्हील एनालिसिस में 30% इफिशियंसी के साथ में वो इफिशिएंट होगा, क्योंकि जो गैसोलीन इंजन से जो एमिशन प्रोड्यूस होता है वो एमिशन प्रोड्यूस नहीं होगा इलेक्ट्रिक व्हीकल से। और अगर इलेक्ट्रिक व्हीकल को हम लोग मेथोडोलॉजी डेवलप करते हैं बाय चार्जिंग द ईवीज with the help of the renewable energy like a solar energy, like a wind energy, then it will have 100% of the efficiency as far as the carbon dioxide emissions are being considered. ठीक है, ये दोनों में फर्क है। लेकिन सोलर चार्जिंग या रिन्यूएबल एनर्जी पे चार्जिंग करने का मेथोडोलॉजी आप जैसे इंजीनियर्स को, आप जैसे फैकल्टी मेंबर को अपने स्टूडेंट्स के साथ में डेवलप करना पड़ेगा। ठीक है, इट विल टेक सम टाइम।
सर, और एक क्वेश्चन है कि
हाँ
जो लिथियम और कोबाल्ट से जो बैटरी बनेगी अपनी,
हाँ,
सर इसकी माइनिंग अगर इंडिया में भी शुरू हो जाती है तो क्या ये माइनिंग से पोल्यूशन नहीं होगा? और
नहीं, माइनिंग से जो पोल्यूशन होता है वो तो होता ही है, लेकिन कैसे है कि आने मतलब कैसे है कि आईसी इंजन व्हीकल यूज करने की जगह हम लोग अगर मान लीजिए कि वही से अभी पोल्यूशन कौन से स्टेज पे होता है, ऑयल रिफाइनरी में पोल्यूशन होता है। ऑयल रिफाइनरी से फ्यूल चला जाता है पेट्रोल पंप स्टेशन तक, फ्यूल पंप स्टेशन पर, वहां पोल्यूशन होता है। ठीक है, और फिर बाद में व्हीकल में जाता है तो वही वहां पे भी पोल्यूशन होता है। तो ये अगर 3 सेगमेंट में अगर हमने पोल्यूशन को कॉन्सेंट्रेट किया, तो इलेक्ट्रिक व्हीकल में एक जो सेगमेंट है रोड के ऊपर जो गाड़ियां चल रही है वहां से तो हमारा मिनिमाइज हो रहा है, वहां से हमारा 30% तो भी कंट्रोल हो रहा है। तो इसलिए कैसा है कि माइनिंग में जो बैटरीज बनाएंगे तो माइनिंग रिसोर्सेस निकालने के लिए या माइनिंग का जो एक्सप्लोरेशन करेंगे वो तो पोल्यूशन होना ही है, हर ऐसा किसी ना किसी में तो होना है, लेकिन हमें देखना है इफिशियंसी पॉइंट ऑफ व्यू। 100% परफेक्ट तो इलेक्ट्रिक व्हीकल भी नहीं होंगे। 100% इलेक्ट्रिक व्हीकल से अगर पोल्यूशन कम होगा ये तो हम बोल ही नहीं रहे, ये तो होगा ही नहीं। ठीक है, लेकिन उसको कंट्रोल करना पोल्यूशन को, एयर पोल्यूशन को, और गैसोलीन इंजन से जो होने वाला हजार्डस गैस जो निकलता है कार्बन मोनोऑक्साइड विच इज बेसिकली रिस्पॉन्सिबल फॉर द ग्लोबल वार्मिंग, दैट कैन बी कंट्रोल। अभी हमारा प्राइम एम जो है पेरिस क्लाइमेट एग्रीमेंट के ऊपर हमारा फोकस है। ठीक है,
ठीक है सर। ठीक है सर, थैंक यू।
एनी अदर क्वेश्चन?
Hello, sir.
हाँ
Dr. Satish Patil here.
हाँ, बोलिए सर।
I would like to ask one question about after the lifespan of the battery is over,
हाँ
the issue of disposal of the batteries will be a
हाँ,
major task in front of the
यस
electric vehicles.
यस यस।
How it can be tackled, sir? Because disposing the battery components will be a
No,
major headache.
we have to find out the solutions to disposable of the batteries. Currently, no solution is available. Solid waste management people, those are working in this particular area in the civil engineering, they have to now find out the solution for the disposable of the batteries, how it is to be disposed of. अभी हमारे देश में आईसी इंजन के इतने सारे व्हीकल्स पड़े हुए हैं, पुराने व्हीकल्स जगह जगह गैरेज में, अलग अलग जगह, तो इसलिए उसका ही सोल्यूशन अभी अपने पास है नहीं। ठीक है, उसको ही अभी गवर्नमेंट ने एक पॉलिसी निकाली है कि 15 साल पहले गवर्नमेंट के जो व्हीकल है उसको डायरेक्टली स्क्रैप करना है, कन्वर्ट करना है उसको मेटल में, मतलब बेच देना है या स्क्रैप में बेच के उसको निकाल देना है, सो दैट इट कैन बी यूटिलाइज। तो जो बैटरीज है उसके लिए सॉलिड वेस्ट मैनेजमेंट पीपल हैज टू फाइंड आउट सर्टेन सॉल्यूशंस फॉर रिसाइकलिंग ऑफ द बैटरीज। Batteries can be recycled, so we have to find out our own solutions. ये प्रॉब्लम जैसे
Okay.
जैसे बढ़ेंगे वैसे वैसे वो बढ़ेगा, मतलब।
Right now, the electrical vehicle industry, it is in a infancy stage, sir. We can say
Yes,
hardly 5 to 10 years has been over
yes,
for the launching of the electric
yeah,
vehicles.
yes.
As the time will pass on, the electric vehicle batteries will have to be replaced, right?
Hmm.
So, how to dispose of that worn out batteries after their lifespan create a
So
major
that is
problem, sir.
what the solution you have to find out, Dr. Satish Patil,
Yeah,
along with
yeah.
your student.
Right,
ठीक है?
right. That will be a major task in front of the
Yes, yes,
academicians as well as the engineers
major,
also, sir.
yes, major challenge in front of us. That
Yeah.
solution has to be find out for battery recycling, and if any components are to be discarded, or it is to be considered as a scrap handling is one of the biggest challenge. We have to find out the solution for that.
Okay,
Definitely
okay.
something will come out.
Yeah, okay, okay. Thank you. Thank you, sir.
I think one more question is there in the chat box by the Dudmal sir, regarding the basically the speed variations. Motors runs at a constant speed. In case of the electric vehicle, the speed is managed by the power electronics, which basically adjusts the frequency and the voltage of the electricity delivered to the motor. So therefore, the this is differing from the internal combustion engine, which is relying on a multi-speed transmission system to avoid a wide range of speeds and the torque. So here in this case, in case of the EVs, this is managed by the power electronics devices, which are basically delivering the voltage to the electric motor. So it is to be managed by the power electronics. I hope I have answered your question. Thank you. Thank you very much. Thanks a lot.
Thank you, sir. I'm here again to propose the vote of thanks. It is a great honor and privilege to deliver the vote of thanks on this excellent and informative session on electric vehicles, a drive towards a sustainability transport system. On the behalf of PS College of Engineering, Chhatrapati Sambhajinagar, Maharashtra State, and the organizing committee, I would like to express a sincere thank to our esteemed speaker, Dr. G.K. Avari, for sharing insights on the evolution, impact, and the future of electric vehicles. Your deep understanding of the subject has certainly enlightened us how EVs are not just a technological advancement but a necessary step towards achieving environmental sustainability. I express a sincere gratitude for taking the time to share your expertise with all of us. A big thank you to our audience for your keen interest and active participation. Your questions, engagement, and enthusiasm reflect the growing awareness and responsibility toward building a green future. Let us take this session as a call to action to promote cleaner transportation choices, to support innovation in sustained mobility, and be mindful of the environment impact of our daily travel decisions. With that, I once again thank everyone. Let us keep moving forward towards a cleaner, greener, and more sustainable tomorrow.